Hello guys, I'm back. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design, and today I will talk with you about HAZOP, Hazard and the Operability Study. Let's see how is the relationship between the chemical process engineering, plant design and the HAZOP, and I will do some considerations, do some clarifications, and of course that is not my objective here to exhaust the subject, but I believe that you are not familiar with HAZOP, it will help you a lot. And sorry for being late. Every Saturday I have a new video here for you that are interested in if you are a chemical process engineer and you are interested in working with plant design, every Saturday there are a new video for you. So to start with, let me know where you're from. I am from Brazil, and although I have been working around the world in South America mainly, but also in China. I have been some months in China, and it is very nice to know how far my message reach the people around the world. Not only that, I have at my right side I have another monitor, and I can see the chat from there, so during the live session I can interrupt to answer questions, or eventually in the end I will stay a little bit more time to share with you the answers that I may have related to the questions. And I can see that in the chat there is the Zouzou and also Bruno Rosa. Bruno Rosa, by the name, it may be a Brazilian guy, so it's very nice to know, to have people from Brazil following me, because it's very interesting. I have a mentoring program, and most of people is not Brazilian. It's less than 5% of my students are Brazilian, so it's very nice when I have someone from Brazil. And we have Asma from Algeria. Nice to have you here, Asma. So I will start with some general considerations about HAZOP, and it's my main goal. It's my goal in this live session to share with you or let you know the HAZOP spreadsheet. Let's take a look also in a P&ID markup for HAZOP, and based on that, let's do some discussions. Okay, guys? So how important is the process safety for plant design, and how the chemical process engineer addressed to that? It is very important that if you want to work with plant design, and not only in plant design, but if you want to work with the industry, chemical, petrochemical, oil and gas, you have a strong process safety culture, or a process safety oriented focus, because I say this very often, hazard or accidents can kill not only people but also companies. I'm not so sure if you are familiar with the Bhopal accidents that happened in India some time ago, many years ago to be more exactly, and it was a company from the Union Carbide, and because of this accident a lot of people died, unfortunately, and also the company died, because a lot of responsibilities, fees to pay, and also the brand, and because of that it was extinguished. And it's not only a concern about money, it's about concern about lives. And as a chemical process engineer, depending on the analysis of the causes, and depending on the results of the research, you can be legal involved, so people can go to prison because of that if you neglected some aspects of the safety in a project or in an operation. So that's why it's very important to be aware of that. And remember that if you already work, it's very not stressful, but to keeping the operations running, sometimes we have a lot of pressure on that, not only in operations, but also during the design phase of the project. We have a lot of pressure to keeping going with the deliverables. But if that leads to some kind of unsafe conditions, stop, and at least try be your best to not, you don't need to confront your boss, but you need to manage them in order that you can deal with this. When something happens, something wrong happens, no one will be there to support you. So that's why very, very important to have everything noted, everything registered, and be worried about that and take care about that. And as a chemical process engineer, we are the first person to know the hazards of a plant, because we choose and we design the process, we select or we get involved with the selection of the raw materials, and we know what are the products. So it's not the electrical engineer, it's not the mechanical engineer, the first person to identify the hazards that may have a process may have. Is the chemical process engineer. If I need to choose a solvent to do absorption, and it is the chemical process engineer that will do that. It's not the instrumentation engineer. If we have some kind of flammables gas in the process and the minimum level, explosive level, who wants to know which is it is the chemical process engineer, not the mechanical engineer. What we do is inform to the other disciplines the risks involved, and based on that, they will be able to fill and develop their deliverables. Okay, so based on that, we have many steps in a plan design, and depending on the step of the plan design, there are a better method to be applied to verify the hazards associated to a process. If we are talking about a conceptual design, most often we use a hazard identification analysis. It's something more simpler than a HAZOP, but it addresses the main risks and the main hazard that a project has. But when we are going through the steps of a plan design, we don't need, but it is recommended to have a method that allows you to save time and to do the analysis in a way that can be repeated for any person, and that once you have a methodology to evaluate something, it's easier to people to understand. So is where the HAZOP enters. We use the HAZOP because it is a methodology that allows you to simplify the process, and imagine that you have a checklist. So if you know the HAZOP methodology, you know the steps that must be done to complete the analysis, and because of that, that is very, very important. And to give you some references, the HAZOP, usually it is used in the 3 or 4 main steps of the project. In the basic engineering, when we are finishing the basic engineering, we can consider doing our HAZOP, because you already have a process well defined, you have the control loops of your system, the pipe instrumentation diagram will be already developed, although it doesn't have all information from the suppliers. You already the big picture of the process. And another step good to do the HAZOP is during the detailing design, because this way, when you receive all the information from the suppliers, and when I talk about receiving information of the suppliers, is you already have the vessel drawing, and you know the maximum allowable working pressure, the minimum design mean temperature, and if you bought the pump, you have the curve of the pump, so you have the maximum and minimum conditions that the equipment can work in a mechanical point of view. And another once you finish the HAZOP, there are some procedures that must be done, but during the life of the operation plan of the plant, we also need to do HAZOPs, and in many countries is a regulation requirement to review the HAZOP time to time, so it's important to you that you be familiar with this kind of procedure. And every time that you do, not every time, but every time that a modification in an existing process leads to a new hazard to the process. So this is the main milestones that you should consider doing a HAZOP. And a HAZOP meeting is there are a group of people, a team that participates in the HAZOP, and not necessarily the chemical process engineer will lead that. In my point of view, and I share with some colleagues, is that the person that develops the process should not be the same person that will lead the HAZOP meeting, because we know we tend to have some pre thoughts about the process, and that can influence the people that are participating in the meeting. The HAZOP meeting cannot have too many people, because if you have that, it will disconcentrate the team. You can have side talkings, and that is very, very stressful for the HAZOP leader. But you cannot have too many people, because you will not have the diversification of point of views. And to give you a reference, what would be the best size of a HAZOP team? Around 5 people, -2, more 2, so 3 to 7 persons, people in a HAZOP meet should be okay. But it doesn't, if you have seven people in a meeting, but all of them is chemical process engineers, it will not be good, not so good for the HAZOP meeting. You need to have a multidisciplinary team. What it means? You should have, especially if we are talking an existing plant, you have something from operations, someone very experienced in the operations, because what we design in the paper, sometimes it's different what happens in the real life, or not so different, but with details that people in the design office doesn't know what happens in the field. You should have someone from maintenance team. It's very, very important, because they know the behaviors of the equipment, what happens in the real life. Of course, that you must know the chemical process engineer and experienced one, and all of them, it's interesting that they are experienced people. But eventually, if you are arriving in the company, you will be invited to participate, and it's a time that you have to gain a lot of knowledge, because you will see different people with different vision talking about the same process and the concerns what can happen about that. But if you want to prepare better for a HAZOP meeting as a fresher or as an inexperienced process engineer, what I recommend you is to be familiar or read books that address to accidents, especially in your field of work. For instance, if you work with petrochemicals facilities, look for a CCPS publication that address the main accidents in the petrochemical industry, for instance, and it applies also for oil and gas and other industry that are available. Because this way, what we do in the HAZOP is identify a deviation, find what that deviation leads for, and what is the safeguards or what is the mitigation needed to avoid that kind of hazard to happen. And if you get in touch with publications that are talk about that, you will have a better understanding on how you size, on how you design your process. And this is a good way to be familiar with. So let me return here to the chat. Sandino, nice to have you here, Sandino. Christian, Edward, hello. And I think that we have a South Korean here. The name is very, very difficult to me to understand, but hello. So let's see some practice and let's see some drawings, and let me be a little bit smaller in order that I can share some real documents with you. And remembering that you can find more about chemical process engineering plant design at my website, jeffersoncosta.com, and you'll find links for YouTube, Telegram, my LinkedIn, and also links for my Instagram and my Facebook. So what I want to share with you first is this drawing here. It's a drawing that I got in the internet. So here the HAZOP is a methodology, as I have told you, and what you have your main process, and it is not a pipe instrumentation diagram, it's more related to a process flow diagram. Although we have manual valves here, usually we don't represent manual valves in process flow diagrams, but it is to show you that what happens in the HAZOP. Imagine that you have a refinery, imagine that you have a steam methane reformer process or a separation process. There are specific equipments for each part of the process. For instance, in the separation units, we have the compression system, we have the pre-treating, we have the cold box, and we have the dry ox, we have the storage system. So you will not do the evaluation of the project at the same time. We need to get subsystems in order to evaluate them better, and with that be more accurate and have more efficiency in terms of hazard evaluation. So what is very common is that for each subsystem or node, it is defined as node, we have a different color identified which part of the process we are evaluating at that time. So here you can see that we have purple color, something like yellow, green, and blue. So we have here at least 4 nodes. Each color represents a node, and who defines the node is the HAZOP leader. He is the person that will evaluate the whole documentation and will suggest, he will suggest, but normally people don't say anything against the decision of the HAZOP leader. He will decide what the better nodes represents the system that must be evaluated. Nepal, Sagar from Nepal. When I think about Nepal, I think about meditation, Saga. Let's see here. Let me share with you another drawing. So you can see here that it's a very simplified drawing. It's a process flow diagram, and it's a good start. As a fresher or an experienced process engineer, you are not supposed to lead a HAZOP, okay, a HAZOP meeting. But when we are getting more experienced, it's not desired, but people expect that you are able to lead HAZOP meetings. And a difference between these that you can see that is very simple. We have only the main controls and the main equipment. Now I will share with you the here we have a pipe instrumentation diagram sheet. I remove the stamp, okay, and you will see that the drawing is different because in the pipe instrumentation diagram we have the line name, the line tag, we have field instrumentation, and we have the alarms shown in the drawing. So the main document to be used during the HAZOP is the pipe instrumentation diagram. Although we need some other documentation to support the HAZOP, like the layout or the safety data sheet of the components, the truth is that the pipe instrumentation diagram is the main document if we are talking about industrial design, if you are talking facilities related to chemical, petrochemical, oil and gas industry. So here you can see that it is partially highlighted because we were verifying only what is new to the process. So the clouds means that it is new to the process, and it was outside the clouds it's existing. So it was a way to do the HAZOP of this facility. And you need the pipe instrumentation diagram because when you go to the worksheet or when you go to HAZOP sheet, you need to address the tags of the instrumentation, the tags of the equipment. So if I can identify the pressure at the system and it is a manometer PI 101, I need to inform that in the HAZOP in order to get very specific what are the identifications, what are the mitigations, and etc. We have a question here, based on what the leader specified these colors. The color is arbitrary. You will only avoid repeating the same color for different nodes. So the color is just a way to make it easier to people understand that we are talking about different systems. But how to define the nodes, it depends on the HAZOP leader experience, how complex is the process. If you have a set of equipments that you don't have too much process changes in that node, you could group a set of equipments. For instance, here we have a gas stream that is washed against recirculating water. So you can see that this system as a whole consists of a washing tower, 2 pumps running parallel, and a recirculating system. And could the HAZOP leader defines the node 1 as only the column and other nodes only for the pumps? Yes, it's possible, but it must be what the HAZOP leaders does is verify if it makes sense, if it leads to some benefits to the HAZOP meeting. Okay, so it's more art than something scientific. The HAZOP meeting, there's a HAZOP methodology. Although it's a methodology, it's not 1 + 1 is equal 2. It has some kind of personal experience added to that in order to have good results. Nice question, Azos, Manu, nice question. I hope that I have answered to you. So let's go to the spreadsheet. Let me show you an example of HAZOP spreadsheet. It is in Portuguese, but don't worry about that. As part of the documentation of the plan design, what I recommend you, if you are involved with this kind of evaluation, is to have a cover to all documentation that you do in plan design. It doesn't matter if it is a calculation memory, if it doesn't matter if it is a data sheet for control valve, or if it is your process flow diagram. You need to have a stamp identifying the number of the documents, the revision, the first issue, and the updates or the index of changes of the document. So it's very, very important to you consider that. Here we don't have this kind of information, but we have some administrative information that is very, very important to a HAZOP meeting. So here we have the number of the document, the location, and the methods. In this case is HAZOP. The process, you need to have the big picture of the process, dates, participants. You need to have a registration of the participants to attach to your HAZOP report. And here there are some considerations and premises related to the HAZOP methodology. And what I wanted to show you here is that we have in this system here, it was a system with 4 subsystems. So there was the compression of natural gas, a heating system, the pressurization system, and instrument air system. I will we need to have well defined what are the premises of the HAZOP before starting the meeting, and sharing those information with the HAZOP team. And another thing is that before starting the HAZOP, it's very important that people is familiar with the process. The HAZOP meeting is not the time to people get familiar with the process, because it will take a lot of time to all of people understand what's happening, what's not happening. So the HAZOP is to evaluate hazard and to do hazard analysis. It's not to talk about the scope of the project. It happens a lot if the team is not familiar with the process. It's not the time to solve specific issues. It's not during the HAZOP meeting that you will see that there is a action plan to be filled, and the specific issues should be evaluated after the HAZOP meeting. And what I recommend you, if you are leading this kind of process, is prepare the material before the meeting and share with people before the meeting in order that they get familiar with that. And also the steps in a plant design, there are the HAZOP should not be the first contact with hazard analysis in a plant design. We have in many companies, we have something that is called the piping instrumentation diagram review. And the piping instrumentation diagram review, we have the first contact with hazard analysis with other people of the team. So that there is the time to let the people more familiar with the process. But in the HAZOP, the team should be already familiar with that to save time. And if you are talking about an external consultant to lead the HAZOP team, he or she will get in touch with the chemical process engineer to know more about the process, to understand what is happening, in order that he or she can define the nodes. And so it is what we expected from a consultant if they is not familiar with that kind of process. So the core information that we consider in a HAZOP is the guiding words. So this is where the methodology is constructed from. So we have parameters that we must evaluate in a process, in a node, and the parameters is flow, pressure, temperature, level, composition, and depending on the kind of HAZOP that you are participating, you can have parameters related to startup, shutdown, maintenance, operations, human factor, and etc. And each one, or most of these parameters, will be associated with a guiding word. A guiding word will help you to issues related to pressure, what we should evaluate in the node in issues related to pressure. So we have the high pressure, we have low pressure. In this case, we have without pressure or vacuum, and we can evaluating depending on the parameter reverse and reverse flow, for instance, wrong directed, or it's flow. We use that very often, and others that can appear in the HAZOP meeting. And so we have the guiding words that is very, very important to let the HAZOP meeting work properly. And we have the risk matrix. So every hazard analysis is associated in some level for the risk matrix. And what is the risk matrix? Is a table that refers the severity of the event with the frequency of the event. And although it is in Portuguese, you can intuit from it that if we get combinations in the green area, it's good for the process. We don't need to do anything. If we get in the red mark, it's not good for the process. And if we have a yellow or orange, it's something intermediate between the red and the green. So when we are developing, when the chemical process engineer is developing his or her pipe instrumentation diagram, our target is to have all the issues related to safety at the green area, because this way it means that the process is safety. We will not have major concerns about some kind of accidents. If it happens, it is all well addressed, but sometimes it's not possible because we were not able to identify a hazard or a consequence of parameter changing, or because we have some constraints related to the capital. So in the HAZOP, when we imagine that if you add something for safety during the design, and that goes to the HAZOP, and although it's not too much necessary, sometimes what happens is that no one will remove that from your process, because it's a big responsibility. Remove something that in theory leads to a safer system. On the other hand, if you miss something that should be there and it is found in the HAZOP and goes to the action plan, most probably it will be authorized to be included because we are leading the process for the safer side, the safer region. And of course that it depends from company to company, but by experience it is this way that it happens. And here let's go to the node 1. As I told you, this analysis had more than one node. It was 4, but just to give you an example for you, I bring here some lines that you can be familiar with that. So here we have the identification of the node, description, and the pipe instrumentation diagram sheets. So a node can pass through several sheets before between its beginning and its ending. So it was the case here. And I remove the information because it's based on practice, and I am not here to get in trouble with my boss, with my company, okay, with the company that I work to. So what I want to show you is that in a HAZOP meeting, we have the deviation, and the deviation is related to the guiding words. So the guiding words will help you to identify the deviations of the process. And what is the high pressure in a HAZOP analysis? The high pressure, low pressure, or the guiding word high, guiding word small is higher above the normal operating conditions or less than normal operating conditions. If I have a process that can operate between 10 and 20 bar G, what I will consider about high pressure, it is what is above 20 bar G, okay? And when I say operating range is different from the design range of a system. So here in the node, we will identify the deviation, and with the guiding words, it is high flow in this case. In the node, we will identify what are the causes of this high flow in the node. Let's suppose that we are verifying. Let me see here. Let me return here. Let's take this drawing as reference. It is not the same drawing that was used to that spreadsheet, just to clarify to you. But let's suppose that we have here we are evaluating the high flow in this node, and we are evaluating the high flow at the discharge of the pump. What can lead to a high flow at the discharge of the pump? One thing is that if we increase the level of the liquid, we will increase the pressure, and when we increase the delta P, we will have more flow through the pump. Okay, I am having more maximum allowable working pressure. NPSH available is higher, and my pump, if I don't regulate the discharge, I have more flow through that. And I can have high flow also if my tube rupture for any reason. So if the tube rupture, I will not have the pressure drop against the pump discharge, and I will lead to more flow through this segment. So it is, so we list the consequences in the consequence tab or the consequence column, and we verify what is the severity of that consequence, considering that we don't have any kind of safeguard to prevent the process from that. So the severity you will find based on the matrix of risk. So I have the severities from neglectable, desprezable, and I'm not so sure if desprezable in English is desprezível in Portuguese, okay? And we have moderate, severe, and catastrophic. So based on that, we choose what address more to the analysis. And we need to have, before starting the HAZOP, is a parameter to classify what is severe, what is neglected. So we have here categories of severity. So what is neglectable is operation, problems, recovery. So if it's something that is an operation problem but it's recoverable, I can classify it's neglected. However, if the issue that happens can kill someone, so internal influence, or if can lead to multiple injuries outside my plant, I can classify that as catastrophic. And the risk matrix is always associated with a reference, so about frequency and about severity. You can see here that we classify as frequent, probable, occasional, remote, or improbable. And we have references here. If it happens at least one time per year, we can consider that it's frequent. If it's one time in 5 years, probable, and it's this way. So here, the chances that I have to break my pipeline, if I break the pipeline, what happens? It's something severe? No, because in the first site I have water, recirculation water. So probably it's not as the severity, it's not high, it's a low severity. And what kind of indication I have to this case? So we go to the instrumentation of the process, we go to the procedures of the process, and we verify how it's possible to identify that the deviation happens in a process. In this case, what I have is the level of the column, because I have an operating level, and if it decreases too much, I will know that, because in a recirculation loop, it should be constant or more or less constant, because I have blowdowns time to time. And we add here the identification of the instrumentation. Here you can see that it is in a generic way. That is not recommended. What is recommended is to inform the instrumentation tag. So for instance, in this case, what we'll say is that we have the LI 260 that informs me if I'm losing the level of the column. So this way, I go to the team, or the HAZOP leader most often that fills this table, and I add the information here. And the next column is related to protection. What protects the process from the hazard or from the deviation that is caused by high flow? So what protect it is the design. I have chosen a material that handles the pressure of the system, the temperature of the system, so it will not break because of the process conditions. And it is located in the plot plane in a way that I don't have a truck that can crash into this vessel. So this is the protection that I can explain here in the protection column. And based on that, based on the indications I have, based on the protection I have, it's time to classify how is the frequency to this cause happens with this deviation. So here we consider all the safeguards, and we can classify, for instance, as remote, because with all of these, it's not expected to happen. And just let's return here. How much is remote? Oh, sorry. In 30 years, I don't expect to have this kind of issue in my plant. So this is a reference that we have. So based on the severity and based on the frequency, the table do automatic classification. In this case, in the spreadsheet is filled automatically. So we got to the here. Let's change here. So neglectable. So you can see that the risks is acceptable, and I am in my green region of my risk matrix. So should I do or should I add any other instrumentation, any other create any other procedure to the system related with this deviation? At first sight, not, because it's already safe for operations, so you don't need to expend more time than are needed to increase the safety of the process related to this deviation. So what the HAZOP does is to get the guiding words, and now instead of talking about high flow, we'll talk about less flow. And when we finish the flow parameter, let's go to the pressure parameter, and what can lead to high pressure, what can lead to less pressure, and we use all the parameters that make sense for that node. In this way, we will have the analysis of our system, and when we have some kind of issue, if we have something let me return here. Let's suppose that we have another deviation here and severe. Let me change here. So if we get in a region of the risk matrix that is not acceptable, we need to address action to solve that. So that's where we go to the action plan sheet. The action plan sheet, everything that is not acceptable or that should be improved is listed, and we have the node number, we have the number of the item, the deviation that is associated with the risks. Here we have this, don't consider that, okay? It is get from the previous sheet. So we have to solve this item number 2. And what are the actions recommended? Usually during the HAZOP meeting, this will be addressed during the HAZOP meeting. So we'll have some kinds of considerations, revise the calculation, revise the material, verify if the material MAWP is good or not. So this kind of action will be registered in the action plan. And what is very, very important is that the action plan must be finished in a reasonable time, because that if you get too much time to solve your action plan, depending on the company, your project will not, you will not change to another step or to another phase of the project. But what is worse is that if you do changes during the construction of the plant, it's much more expensive than during during the design. So that's why you need to be aware of that. And we have the status, a schedule, or a time to conclude this action plan, here item number 2. And we have the when it occurred in fact, when it was finished in fact, so it is the conclusion. Sometimes people add the name of people here. I don't like to do that because people from the team can change. So I prefer, it is my point of view, I prefer to identify the main discipline responsible for that. So it is the mechanical engineer that should solve this, should solve this action plan. It's the process engineer. So I prefer to identify the discipline and not the person, because the person can be relocated, can be fired, can be hired. So I prefer to do this way. And there is a field here for resolution. So the action or recommendation was that, but what was the resolution? What was the real resolution for that? So we have a field for that. And once we solve it, once we propose it another a solution, we reevaluate the severity, we evaluate the frequency, and of course that it should lead to acceptable condition, because if it's still not acceptable, something is wrong. Your solution was it's not a solution. It's only a solution if it gets the region for green. And there are some others, in this case, in the spreadsheet, there are some other columns for others recommendations, and the responsible and the schedule. Okay, so this is the sum of the sheets that we have associated with HAZOP meeting. And in this specific sheet, it depends on from company to company. Each one of them has its specific HAZOP sheet, but in this one we have a sheet named parking lot. Is that because sometimes there is some kind of issues that is discussed in the meeting that is not necessarily related to the hazard conditions analysis. So what we do is to register that in the parking lot in order that verify with the customer if the verify with the customer what is the battery limit, where is the battery limit, for instance. So we add this, and as the action plan, we have also the status, the responsible, the schedule, when it was finished, and what was the resolution. And finally, here we have a summary of all the notes and what, how many scenarios was evaluated, how many was red risk, orange risk, yellow risk, and green risk. And with all of these, you are ready to develop your HAZOP report, because this is the spreadsheet. But as I told you, if we are talking about plan design, we are talking about deliverables, and in many cases what's happening is that we get this and transport this for a document, for a report, in order that you have the documentation issue during the project. So guys, I talked a lot about this, and if you have questions, let me know, because I don't have too much to add about this moment. And I know that it was very a summarization, okay guys, There are much more to be added to the subject, but for as a introduction, it was what I would like to share with you. Remember, you can join my Telegram channel in process to have more about chemical process engineering plant design. I have a free course in my website, jeffersoncosta.com, with more than 7 hours of chemical process engineering plant design, the roles and responsibility of a chemical process engineering plant design. And on May, I will have a special workshop. I will do a special workshop, and I am working on the schedule. I'm working in the registration, and probably next week I will let it available to you to register for free and online. Okay. So if you don't have any question, it's time to go. I have some classes to share with my students today. I probably will talk to them about atmospheric distillation in ice and high seas. And guys, it was very nice to be here with you. I'll see you soon in the next video. Bye bye.